Today we're talking about how to do mixed numbers. And the definition of a mixed number is it's a mix of a number that is whole and a fraction that is not. Correct?
Yep.
So, the theme of the day is dude, use them both. We are very, very used to finding that common denominator, changing the numerator so that it matches the denominator, and then doing our adding or subtracting. It is super easy to forget a step. Because remember, we don't generally make mistakes on the complicated stuff that we have to think about. We make mistakes on the simple stuff that we take for granted, right? So if I give you this question, 3.5 plus 2 3/4. First off, we know we can't add halves to fourths. We have to have a common denominator, right?
Yeah.
And we can look at the 2 and the 4 and definitely mental math this one. 2 times 2 is 4. Top and bottom same. So I'm going to change that to 2/4, right? Now I can add my 2/4 and my 3/4, right? You know what? For the sake of making it easy, change that to a 1/4. 2 plus 1 is 3/4. 2/4 plus 1/4 equals 3/4. Now I've got my holes left, right? 3 holes plus 2 holes. Flashback to kindergarten, peeps. What's this equal?
5.
Good job. Glad you got that right. Been super embarrassing on YouTube to be like, 4! Now. Yeah, what's up? Huh? Yeah, we started the video, but it's okay if you got a question. It does get more complicated than that, but not a whole lot. Carrying and borrowing. Carrying is, back to my colors, if I've got a 19 and a 3, when I add my ones, I'm going to have too much to fit in just my ones column, right? I'm going to get this. So what did I do with that 1? I promoted it, right? If it doesn't fit over here, I found the place where it does fit and I put it over there. It doesn't fit my ones column, it fits my tens column, so I moved it over, correct?
Mm-hmm.
We're going to take that same idea and we're going to apply it to fractions. Let's have a 3. Let's take that original problem we had before I changed it, because I realized we had to carry. So I know I need to change this to 2/4, correct? That's pretty obvious mental math. Now I can add. My whole numbers, I've got 5. I know my common denominator is fourths, and if it's not broke, we don't fix it. We've got a common denominator. We're not even playing. We're just leaving it. I have 2/4 and 3/4. 2 plus 3? Yes.
5.
Glad somebody's awake. Yeah, 5, right? So I've got, of course, we're working with mixed numbers. I've got a 5 and a 5/4, which is a mixed number and an improper fraction. Is it okay to have both? No. You can either have a mixed number or an improper fraction, but I've got 2 different ways of expressing a whole, right? Is there a whole stuck in this fraction? 5/4? Yeah. How do I get it out? It's all, help! Help, I'm locked in! How do I take it out? What do I do with it? What do you think?
You just subtract it?
You do. So how do you go about subtracting it? And there, all the hands are like, shoo! I don't know. What do you think?
Okay, so 5 minus 4 is 1.
5 minus 4 is 1, right? We know 4 makes a whole group. We know we've got 4 extra 4s in here. So if I subtract my denominator from my numerator, or I see how many 4s I can just take out of my numerator, I get this. Is that what you're aiming for? Now I've got another math problem, right? Your kindergarten teacher says you can do this. What's my answer when I finalize it? This is carrying because this 1 is stuck in this fraction. We have an improper fraction as part of a mixed number. So we need to unstick it and promote it to our wholes. What if, can we see this? We can see this. I had 5 and 10 fourths. How many fourths can I take out of that numerator?
2.
Is that okay? Yeah, right? Is there a rule breaker way to do this? No. Because basically when we're working with fractions, we're just kind of playing with little number tricks that we know work in order to make the fraction make sense, right? So as long as we don't change the numbers, we just change how they look, whatever we're doing is fine. So I can take this 5, I can take 2 groups of 4 out of 10, which is 8, and leave myself with 2 fourths, right? So if I simplify that, what do I get?
8
7
2 fourths.
and 2 fourths. Is that simplified though?
Yeah.
It's getting warm.
No.
Nope, what is it when it's simplified? We simplified our wholes. How about this fraction? 2 fourths?
It can be 1/2.
Yep. It's really not that bad, is it? Nah. It kind of takes that common denominator stuff we've been doing, and it adds kindergarten math to it. Basically, what we have to recognize when we're working with these mixed numbers is we can take a whole out of our mixed numbers, or we can take a whole out of our fractions and add it to our mixed numbers. Basically, it doesn't matter where our wholes are at as long as we have them all gathered up in the same place. We can't have some over here in the fraction and some over here in the whole number. We just have to have them all put together in the same place. Why? Because that's the most simple way to talk about it. It's the most simple way to look at it. And if we're dealing with fractions, simplified is what we're going for, right? So I'm betting if carrying makes sense, borrowing is going to look pretty close to the same. 6 1/4 is our final answer. Let's say 7 1/3 minus 4 2/3. Can I take 4 away from 7? Yes, definitely, no problem. Can I take 2/3 away from 1/3?
No.
No, I cannot. I don't have enough thirds to subtract. Does that mean I just get to drop a marker and go home?
No.
No. Are there more thirds over here that I have access to that I just kind of have to tinker with them and make them look the right way? I see you looking at them. Where are the rest of my thirds in this number? They're hiding out. They're undercover. If I took these fourths and I added them over here, would it make sense that I could do something with the 7 to find more thirds? It's on the tip of his tongue. He's like, yes, but I don't exactly see what. When I do it, you'll be like, oh, okay. What do you see? I could take 1 out of 7. I don't need it. I could take as many out of 7 as I want, couldn't I? I only need 1, though. Take that 7, make it a 6. And now I've got a floating 1, right? Ooh, floating 1. My denominator is 3. If I split, I'm not going to actually split this because I want to keep it. If I split this 1 into 3, I get 3/3, correct? So I add the 3/3 to 1/3, I get 4/3. Can I subtract now?
Yep.
2/3 minus 4/3?
2/3.
4 minus 6?
is 2.
Can it be reduced? Nope. 2/3 simplified.
Yeah.
2 and 2/3. So, if I was going to do this when you were a little kid, I'd have done this. And this would be borrowing, right? Or regrouping. 11 minus 2. Can I take 2 away from this one? No. I need to go over here. Make that. Oh, no, I don't. And just bring it over, right? Let me grab us a better one. Can I take 2 away from this one? No. So I have to go steal one from over here. Now can I take 2 away from 11? Yeah, sure. I kind of did the same thing, right? I didn't have enough thirds over here, so I just went and borrowed some from my holes. Is that an acceptable thing to do?
Yeah.
Yeah, sure. Because we didn't change the number, did we? We just messed around with the pieces and made it look a little different.